All right, we've got a pretty difficult topic this week. We're looking at function inverses and inversive relations. So I want to walk you through this assignment a little bit so you can get an idea of how to solve these. It's really easy to make mistakes along the way here too, especially when you're dealing with literal equations and isolating variables. It's really easy to make some mistakes. So I'm going to walk you through a few examples and hopefully this helps you out a little bit. Now, how do you find the inverse of a relation? Write the steps below. What I put was I swap the inputs and outputs, and then I'm going to isolate y after I do that. Let me show you what I mean. Now, first of all, when you have an inverse function, right, you have an input and an output, x and y. When you're looking at the inverse of that function, what happens is basically the output and the input swap places. So xy becomes yx. So what I did for this first relation here, you'll notice I isolated my variables, or I highlighted them rather. I have y and x, right? I highlighted them. You notice I drew a little arrow here because they're going to swap places. So whereas up here, let me go with another color here. Up here I had y, well, son, it becomes x. Whereas up here I had x, it becomes y. And now your next step is you want to isolate y. You want to isolate this y here, and that can be a bit tricky. So let's walk through what we need to do here to get rid of y, right? Let's look and see if there's any addition or subtraction happening around there. Because again, you're using inverse operations. I'm going to draw a line right down the middle here too. This can be helpful. I'm going to subtract 8. But if I do that, I want to do that on both sides. So I'm going to do it over here too. What does that give me? I get x minus 8 equals 4y. So now I'm almost there. My goal is to get y all alone. Now, since I'm multiplying y here, I'm going to divide each side by 4, basically undoing the multiplication. What I end up getting over here is 4 over 4, they cancel out. I'm left with y. And now over here, I'm left with x minus 8 over 4. I'm going to take this one step further. I'm going to use the distributive property. I can use that for not only multiplication, I can use that for division as well. So since I'm dividing the whole thing of x minus 8 by 4, I'm just going to split it up. So I'm going to do x divided by 4 minus 8 divided by 4 equals y. I haven't changed anything. I'm still dividing everything by 4. All I did was I did it to each term now. I can simplify 8 over 4. I get 2. And I get y here. And maybe I want to even change this a little bit. I'll show you what I mean. If I have x over 4, that is the same thing as doing... Oh, that looks awful. Let me fix that. That's the same thing as doing 1/4 x. Why? Because if I'm multiplying these out, right, I'd be multiplying my top values. I can always rewrite x as x over 1 if I want to. If I do that, 1 times x gives me x. 4 times 1 gives me 4. So by writing it out this way, I keep it in slope-intercept form, which sometimes we like, especially for graphing them. It's a lot easier to do it that way. So again, this is a bit tricky. So you gotta watch out for your steps. The first step I did was I swapped my x and y's. They switched places. Then I isolated y by using inverse operations. I undid the addition and subtraction first, and then I undid any multiplication or division, just like you would do with a typical two-step or multi-step equation. Let's try another one. Let's see. One's a little more difficult. Let's try y. Number 3, excuse me. So again, I'm going to figure out what my variables are, y and x, and I am going to swap them out. Y becomes x, x becomes y. Because again, with an inverse function or an inverse relation, the inputs and outputs, they trade places. Now again, my goal is I want to isolate y. So I'm going to undo that addition and subtraction first. I'm going to write down a nice line down here so I can keep track of stuff. I'm going to add 2 over here. I'm going to add 2 over here as well. These cancel out. I'm left with x plus 2 equals 1/2 y. So I'm getting there. I'm making some progress. Whoops, I did not want to do that. Now again, my goal is I want to get y alone. To undo multiplying by 1/2, I'm going to multiply by 2 over 1. Multiplying by the reciprocal. And I'm also going to do that over here too. So when I do this, guess what? These are going to cancel out. I'm just left with y. I like that. Over here, 2 over 1 times x gives me 2x. 2 over 1 times 2 gives me 2. So I get 2x plus 4 equals y. It's in slope-intercept form, which I like. It makes it nice and easy to graph when the time comes and I have to graph it. But again, hopefully, there are some steps here that you can easily mix up, such as, inverse operations, isolating variables. But the key to remember here is when you're trying to find the inverse of each relation, you're swapping places for x and y. So say for number 2, I'll help you set it up. Again, I'm going to swap places. X equals 2y minus 6. And then I would isolate y. And for number 4, I'm going to do the exact same thing. Swap out y and x. Because again, when you're doing an inverse function or an inverse relation, the inputs and outputs trade places. And that's what these represent. Remember, y is an output, x is an input. And they're just trading places. Hopefully this helps you get started with this. I'm going to go over a few other problems on this, but hopefully this gets you started at least with finding the inverse of each of these relations.